Let's talk about assessing normality. So in stats one, for the most part, we assumed normally distributed based on the wording of the problem. So the problem always told us whether it was normally distributed, or if it was unknown, then we assumed it wasn't normally distributed. We kind of had just a pitchfork in the road. It either said it or it didn't. But realistically, we can test for normality in data sets, whether they're small or large. And in this section, we're going to learn what kind of techniques we can use, specifically using Rguroo. So there is ways to do this out by hand, but since we have technology at our fingertips and it's much faster and quicker than trying to calculate and graph these things out by hand, we're going to use Rguroo in order to test for normality quickly. So a normal probability plot is a graph that plots the observed data, so the X values in your data set, versus their Z-score. So in order to do and you would have to first calculate the normal standard score, the Z-score, normal score, they all the same thing. And if you recall, there's a tiny little formula for that, subtracting your data value minus the mean and dividing by the standard deviation. And if you have a large data set, well, obviously that would take a lot longer to do to calculate all these Z-scores. And then you create a scatter plot and you're taking a look at what is the pattern of the dots in the scatter plot. If we are normally distributed, then you will see that the Z-scores of the observations depend on the observations. And that is the language we use in linear algebra. Or just linear lines. Okay, the y depended on x. Here, the z-scores should depend on the x values as well, creating a linear line if we do indeed have a normally distributed set. So graphically, like I was saying, if there are enough data values to draw a histogram, so if you have 30 or more data values, you can go ahead and draw a histogram, and you'd be looking for a bell-shaped curve, symmetric curve in that histogram. But if you have less than 30 data values, then that's not typically enough to draw an accurate histogram, and therefore you should create a normality probability plot and look to see if, when comparing the data values to their z-scores, if they form a linear pattern. If they do not, then the set is not normally distributed. And if they do, then it is. There's also a normality test that Rguroo provides with p-value, and we can double check that the data values are normally distributed with that test. Okay, inspecting the histogram is very easy in Rguroo because there's a normal test that can go with the histogram, and it will draw a perfectly bell-shaped curve on top of your histogram. And then you are simply looking to see if the shape of the histogram approximately matches the bell-shaped curve. So I've written out the steps for this procedure. So step one, I can read through these, but I'd rather show you. But this is just kind of to remind you how to get a normality plot. So some basic steps, and I will show you how to do it right now. So let's take a look at this data set. And again, I'm assuming, I don't want to assume that you all took stats one with me, so that when I do these problems out in Rguroo, I am going to start from the beginning of how to create a data set, how to use the repository. So this first example will create the data set considering the data values are quite small. There's only 10. And the second example we have today is much larger. There's 100 data values. So we will use the repository for that. Let's see, we have these ages of students enrolled in the course, and we're curious to know whether the small data set is normally distributed so that we can do our analysis or whatever we want to do. So right now, let me switch over to Rguroo, if I can find it. Of course, I can't find it at the moment. Hold on. There it is. Okay, so sign into Rguroo. Go to rguroo.com and click sign in. You should, once you sign in, you should get to this screen. Again, if you took stats one with me last semester or last semester, then your Rguroo subscription is still valid. You don't need to purchase a new one. If you did not take stats one with me last semester, Then if you bought the Hawks bundle from the bookstore, you should have an access key that came in that bundle. If you did not purchase your Hawks access through the bookstore and you purchased it through online, then you just have to purchase the Rguroo access through this site. And I have those steps posted for you in Blackboard. So once we get to this point, we're going to come to data. And you're going to go to data import. You won't have anything in here if you didn't take stats 1 with me. So this will be blank. I just have a lot of stuff because I've been teaching this for a while. Go to data import and we're going to create a new data set. Be careful, creating a new table and creating a new data set are two completely different things. We will start talking about the table when we get to ANOVA, but right now let's create a data set. So first thing I like to do is create how many rows I need, how many data values, because it makes it easier to enter in the data values. So a reminder, our set is 10 data values. So this button up here is adding a row, and I'm going to keep clicking it until I get a count of 10. Now I'm going to double click in this first box and start typing the data values from the PowerPoint. Now if you click enter, you're going to have to keep double clicking, which is annoying. So instead, use your down arrow on your keypad, and that will keep all of the numbers live. So it makes it easier for you to enter in the data values. Again, this is a really handy thing to do when your data set is very small, because this makes it very easy for us to enter in the data. When our data sets are very large and they're Hawks learning data sets, they're already preloaded in here. This is technically preloaded too, but I wanted to show you how to create a data set because not all our data values, not all our data sets will work in this class are Hawks data sets. So in some cases, we will have to create them. In other cases, they'll already be in Excel and we can just import it as an Excel file and it will populate in our list here. So now that I've entered all the 10 data values into Rguroo, I'm going to give the variable a name. And since these were ages of students enrolled in a class, I'm just going to put age. And then you're going to want to give your data set a name. I like, especially when they're examples, to label them the section and then click Save As. I'm actually not going to click the Save As because I've done this already. So it's already in my list. But once you click Save As, you'll see it pop up in your list here. So let me close the editor. I always advise students to check to make sure that their data set was created or imported properly. So double click in the list after you're done. Make sure that you only have labels up in the gray area and that all your data values ended up in this white boxes. Okay, so this typically is an issue when we import. If the Excel file doesn't have a row of labels, then one of our data values will be up here and it won't be in the calculations, and that's a problem. Or sometimes data sets have more than one row of labels, so then you'll start getting labels in the data values and that will mess up your calculations. So this is literally will save you half the trouble when you get error windows popping up when you're trying to do some calculations. Double check that your data set imported properly. Now that we have the data set imported, we are going to come over here to analytics and then to analysis and then to mean inference. So we're not actually doing a hypothesis test or a confidence interval, but this is where we can actually plot normality. So we have only one population. We're not working with data sets with two populations yet, although that's coming up. Once we get into our mean inference screen, and again, you can pause this video at any time if I'm going too fast. You're going to want to select your data set and select the variable. Our data set only has one variable, so that makes it very easy to figure out. It automatically calculates a mean and a standard deviation and a sample size for us. And here's our confidence interval and hypothesis tests. If you took this with me last semester, you've done a lot of work with those tabs. But we don't need those right now. We just need this normality plot, and we might as well do the test or normality to double check. And we click our eyeball. So now I see that here is the plot and the dots do follow a linear path. To confirm that this is normally distributed, I come down to the normality test and I see that the null hypothesis was set to the data values being normally distributed And we just take a look at this p-value to determine whether to fail to reject or to reject. So recall, if this p-value is less than 0.05, which is the default setting, then we would reject this. If we're then we would be saying that the data values are not normally distributed. But since this p-value is quite large, 0.9, we are failing to reject the null hypothesis. And therefore, we are concluding that the data is normally distributed, which is also seen in this plot. So when you're working with small sets, this is a very quick way to check whether the data is normally distributed if the problem didn't already state it for you. Now, when we're working with a much larger data set, so in the PowerPoint, and instead of switching back, because I would just be showing you that a data set exists in there and then moving back over here. But in that PowerPoint, the next data set for the example is about housefly wing length, and it has 100 data values in it. So when you see that it has 100 data values in it, you're like, oh, well, I could do a plot like this one, but instead I might want to make a histogram. So first we need to access that data set. And since it's a Hawks data set, we're going to go to data and data import. This time we're going to go to the repository. So here in the repository, it looks like this. This is all set because I just did this problem. But first you're going to see this and you're not going to see anything below. So you're going to want to scroll. And you keep scrolling until you get to, so see, this is another book publisher who is also Macmillan book that has paired up with Rguroo. So all their data sets are preloaded. And we can see Hawks is here. So there's McGraw-Hill is partnered up. So there's quite a few publishers now getting a hold of Rguroo and partnering. When we click on Hawks, we get all the data sets for the entire book. So here we see housefly wing lengths, which in the PowerPoint, you'll see that's the title of the data set. And if I click import, it's going to add itself to my data set here. I've already imported it, so I'm not going to import it again. But now when I go to my data sets and I go to the bottom, I see, oh, there it is. Again, even though this is already a preloaded set, I like to take a look at it, double click. I see that the case numbers are labeled, or the data values are numbered, almost like in Excel. Why they have two rows that do the exact same thing, I'll never know. And then we have the lengths, which there are 100 of them, same exact values as the PowerPoint. Okay, so our data set is now imported into Rguroo. Now, since this is above 30 data values, we can do a histogram plot instead of the normality plot, although you could do both. So if I go over to plot and come to create plot and click on histogram, you want to select your data set. Here we only have one variable, so we don't have to wonder which one we're using. We only have one. If you were using this to hand in for a mini project or some kind of assignment to me, you definitely need to make sure you put your labels in here. I'm just going to label this check for normality because that's what we're doing. The x-axis will be wing lengths and my y-axis will be frequency. So frequency is already the default. I can change the color of the histogram if I wanted to get fancy schmancy. The only other box we want to select is this normal, because that will actually draw the bell-shaped curve on top of our histogram to help us determine whether it's approximately normal or not. Once we have everything filled out, we hit our little eyeball. And we can see that although it's not perfect, it is approximately normal. Again, if I was unsure, let's say it was a little farther off and I was completely unsure whether this actually would be concluded approximately normal, then run that normal test. Let's do it. We go to analytics, we go to analysis and mean inference for one population. Select our data set, select the variable, automatically get these calculated for us. And then let's click these two boxes for normal. Eyeball when you're done. Okay, I can see that it does fit a linear line and the p-value is really big, which means we fail to reject the null hypothesis that states that the data is normally distributed. So In two ways, we have verified that the histogram is indeed normal by running a normality test, and we can say, yes, this data is normally distributed. Heading back to the PowerPoint for a quick moment. So here was the data set we just worked with, the housefly wing lengths, and that's how I knew what name to look for in the repository. If we take a look at this last example, where we have a doctor that assembled a data set containing the bill length ratios of several hundred different bird species. The bill length ratio is the ratio of the largest bill to the smallest bill measured in each population in each species. Now, if we plotted this, we didn't actually get the data set for this, but if we plotted this, we can clearly see that this is skewed right in the histogram. And if we ran a normality test, we also can see that this has an exponential look to it versus a linear look, which is also confirming that this data set is not normally distributed. It is skewed left or right. And we would have to take appropriate steps knowing that it's not normally distributed in order to apply any analysis. But we won't get to that until the end of the semester when we start talking about different types of tests that do not require the data set to be known to be normally distributed. Okay, this concludes testing for normality using Rguroo with the test for normality and probability plot and the histogram for larger data sets.